Okay, today I want to finish up the looping chapter by talking about pre and post-test loops. We reviewed this a little bit last time, so hopefully it's kind of stuck inside your head, but let's review again. The three different kinds of loops: counter control, pre-test, post-test. Counter control loops you use when you know how many times you're going to iterate. If you know how many times you're going to iterate, loop. If you know how many times you need to loop, like the 50 states, like once for each student in the class, use a for loop. If the collection that you're analyzing already exists, you can use a for each loop to speed that up and simplify that even more. That's what we were talking about before. But in many cases when you're looping, you don't know how many times you need to loop. How many times is the user going to screw up their input? We don't know. How many records are in a database file? We don't know. But we can process them and process them and process them until some condition is false. Both a pre-test and a post-test loop have a condition, just like an if statement. Notice when you flowchart them just like an if statement, except when you get to the bottom, there's an automatic line that comes back up. So when you flowchart your pre-test loops, they come up, they look like this. And we're going to see a live one here in just a minute. Inside here, you have a condition. Under what conditions do I continue to loop? As long as this condition is true, keep looping. Keep looping. Something inside the loop needs to change that condition. If the condition never changes, you have what's called an infinite loop that loops forever. At some point, Windows will get in the way and say, excuse me, you're sucking up too many resources, and it might kill it, but that's a long time. If your program doesn't seem to be doing anything, it's just sitting there spinning, it's probably in an infinite loop. You need to kill it by hitting the red square in Visual Studio to stop it and then try to figure out why it's infinite. In pseudocode, we use the while statement for a pre-test loop. Before I leave here, let me notice that this condition could be false to start with. So if we come down here and this condition is already false, we get out. Like, as long as there are records in the delinquent files file or delinquent accounts file, there might not be any in there. If there aren't, then we go out and we don't do any. Okay, so it is possible with a pre-test loop to skip the contents of the loop altogether. In pseudocode, it looks like while some condition. A whole bunch of statements. What kind of statements? You name it. Can go inside this loop. And then at the bottom, I like to put an end while. You need something at the bottom of your loop. If there's something I've been saying about all your, not all, but many of your pseudocode, it's that you're not putting end ifs and end switches in your pseudocode, so they're hard to tell where they end. In code, you can't get away with it because you have to put a curly bracket there. There's another version that uses an until. That's pretty rare. A couple of languages use it. Until this condition is true. These are opposites of each other. While it's true, loop. Until it's true, loop. When it is true, skip the loop. Just like with for loops, you, the programmer, have to know when you hit the end while, it automatically goes back up and checks the condition again. When you hit the end process down here, it automatically comes up and checks the condition again. If the condition is false, you, the programmer, have to know that you skip to the next statement after the end while. So this gets stuck in a loop until the condition is true, and then it jumps down to here. In C#, use the keyword while. The condition, just like in an if statement, goes into parentheses. So the while loop in C# is really a lot like an if statement, except there's no else. Keyword is while. So as long as this condition is true, we process all these statements. When we hit the curly bracket, we automatically go back up. Check to see if the condition is still true. We don't know how long it's going to take to get to true. We don't know how long it's going to take till we get to the end of file, and that's why we have to use a pre-test loop here. But it's possible that the file is empty to start from. It's a classic example. So let's write one of those, but before we do, there's a flowchart for this program. Should be. Here's the flowchart for the program we're going to write. Again, I described this briefly in the past, but I once went to Pacelli and they are having something called a progressive sale. every half hour, every hour, I don't remember how often it was, the price of an object would come down. So they started it at $100. And then after an hour, it would go down by 10%. And it would be $90. And then after another hour, it'd go down by another 10%, and it would be $81. So 10% of the current price. And they had a minimum of $1. Once it hit $1, that's it. Nobody's bought it by then. Probably nobody wants it. And they stopped shrinking at $1. It's called a progressive sale. And it was just try to get people to buy it for the most value possible and think about who else might buy it. So I thought it was a good example for a loop, because how long does it take for an item's price to go from its original down to 1 if I shrink it by 10% every time? Now, if I was some genius math guy, there's probably an equation that could figure that out. But I'm not. So I don't know how many times I have to loop to go from $57 down to 1 if I shrink it by 10% every time. I don't know. So I can't use a for loop to say, here's how many times I want you to do that. So I have to use maybe a pre-test, maybe a post-test loop. Is it possible that we could skip the loop right away? If the price of the item is already less than $1, then I could just skip it and say, no, I'm not reducing it. Anything that we have for sale that's already less than $1, we're not reducing it. And so in this case, the answer is yes, so that we can use a pre-test loop. So what I need to do is keep track of here, instead of hours, I'm using days. Okay, so think of this in a retail store that is selling items, and every day they knock it down by 10% until somebody buys it. Okay. So I start my day off at 0 because I want to know what the original price is. So on day 0, I'm going to display the original price. My results is a string. We are once again going to be using one of those programs with a text box. Maybe it's a list box. Nope, I think that's a text box again. Yep, that's a read-only text box that contains all my information. Why? Because I want to line stuff up, and list boxes make that a little bit more difficult. So I'm back to a text box again. And we're just going to build this string, just like we did before with our for loop examples. And results is that string. I'm going to save the original price, because what I also want to know is how much of a savings. If you buy it on day 13, what's your percent savings? So I have to remember the original price. And finally, I'm getting how much do I mark off every day from a text box. Another little trick I'm going to throw in here is, what if the user, let me show you the form here if I can find it. I did just a minute ago. Okay. Here's the form. The user puts in the price. How much was this originally? And then what do I take off every day? 10%, 9%, 20%, 15%, whatever I want to do. So these get brought in, but how do users type percentages? Some of them are mathematically adept, and they might type 0.1 for 10%. Others very likely to type in 10. I want to deal with both. So if they type in 10, I'll make it 0.1 behind the scenes, but if they type in 0.1, I'm going to leave it alone. And so that's what this little piece of if statement shows you. No, that's my notes. Back to the if statement. Too many things going on here. This little if statement says, if what the user entered in that text box is greater than or equal to 1, then it's a 2 or a 5 or a 10 or a 20. They want us to do the dividing by 100. If it's already less than 1, it's a fraction, then leave it alone. So it's a nice little technique to let users type their percentages as either a decimal or a whole number. Our program figures out which one it is and converts it. Then, so all this is preliminary. We haven't even started the loop yet. Then I have to initialize. Usually when you loop, particularly a pre-test, post-test loop, you have to do the initialization. You have to do all the counting. All that stuff we put in a for loop often still needs to be done. Every time through the loop, I'm going to calculate the price for this day. So I'm going to calculate the original day price here. Not much of a calculation. I want to know how much my savings is in a percentage. So I'm going to set that to 0 because on day 1 or day 0, I've saved 0. And finally, in this program, I have some headers. I'm going to spit those out. Then the loop starts. And here's that loop. And again, we can see it's a loop. I like to put the word loop on here. Pretty obvious, though. You hit the bottom, you come back up. That's a loop. It's still a diamond. And here's my condition. As long as the price on this day is greater than 1, keep going. Display the latest results. Add 1 to the day. Calculate the new price. And figure out how much you're saving. Then go back up. Are we still greater than $1? Yep, then display it. We just do this over and over and over again. If we're starting at $57, it's 7.5% off each day. Keep going until the price is less than $1. The last price we display will be just barely bigger than $1. When we're done, take that results and spit it out so the user can see it. Here's a pseudocode version of that. Notice how I did this here in Visio. Created another tab and put the pseudocode in one tab and this one, and I split the screen so I could see them both at the same time. Kind of a nice touch. All right, but everything should flow through pretty exactly. Day equals 0, results equals empty string, org price, % off, and then an if statement. If the percentage is greater than 0, then divide it by 100. Then the savings and the day price. I got those flipped around here. Yep, minus 1/2. Oh well. Add the headers. And here's what the loop looks like in pseudocode. While the day price is, notice it's the same, it's just how is it laid out? The text is the same. While the day price is greater than 1. Add the day, add 1, do the day price, do the savings, end while. When you hit the bottom here, that translates to an end while in pseudocode. Then spit out the results. Questions? Okay, and let's write it. See if I can somehow get both of these on the screen at the same time. Not likely. Okay, so again, here's my program. The user's going to enter these two things. When they hit show prices, everything shows up here. There's only one button. It's the show prices button. And a lot of that code I've already generated. Set the minimum price that we want to hit as a constant. Then I've declared variables for the original price, for the % off. My day counter, and I wanted to start that at 0. Let me tweak that. My day price, my savings, and my results, all those initialized to what we want. So those are the variables that I need to handle that looping that we saw on the other screen. Then there's a try catch because I'm going to grab what the user has on the screen and I'm going to format it. Or I'm going to, parse it. If anything fails, we'll take it from there. Now here it just says if the user entered, if the percentage was entered as a whole number. So that's the PCT off. I'm just following my design. I'm over here right now, trying to deal with that if statement. If the PCT is greater than or equal to 1, then divide it by 100. So that happens right here. If the PCT off is greater than or equal to 1. It's only one line, it's very short, so I'm going to put it right afterwards. Then the PCT off divided by equals 100. Remember, that's a shortcut notation for divide the % off by 100, put it right back into PCT off. And that's pretty much what that says. Right? It's just a shortcut version. Then my flowchart says, I'll bring that back in just a second. Then my flowchart says, take the day price, make it the original price, set the savings to 0, already did that. Add the headers to the results. So here I'm just putting headers. I want to see the day number, how much is it going to cost me, and what's my percent savings on that day. What I've done here, we haven't done before. First of all, notice I've already got one result spitting out. This is what I call make it work once. What do you want to do? I want to calculate the statistics and I want to spit out the results. To save a little bit of time in our typing today, I've already string formatted my results, but I did it a little bit differently. This is in those notes. Remember, the string format notes are now on my website. And in that string format notes, I mentioned that it is possible to format multiple numbers at the same time. So now I'm formatting the day, the price, the savings, and this is how I want them spit out. The 0 refers to the first item on the list. Day. Print that with a width of 3. The 1 refers to the second item on the list. Item number 1, item number 0, item number 1, item number 2. So this 1 refers to the day price. Give me a width of 7 formatted for currency. Question? Then this 2 refers to the last one. Format it in 9 width with a %1. Why 9? Mostly for spacing. Notice that there's X number of spaces here. They're the same number of spaces there. X number of spaces here. Same number of spaces there. The reason this is 9 is because the word savings with % takes up 9 columns. I want everybody to line up right. So this is how you can use one string format command to actually format the appearance of 3 numbers all at the same time. Don't have to do it that way. Don't think you need it in the assignment tracker. Just want you to see how. So now back to my design. I've done all of this stuff. I just finished that. So now I want to do the loop. While the day price is greater than 1. Do I have a day price? I do. Here's the original. But first of all, let's make sure this works. Before I put a loop in here to say do it over and over and over again, let's see if it works. Because I do have a day, it's 0. I have a day price, it's the original price. And I have a savings, which is 0. So I can run it and make sure that everything lines up nice and neat before I start worrying about loops. Well, let's start with a $57 item with a 7.5% reduction per day. Not that that matters because right now there's no loop. This 7.5 is going to be converted with my if statement that I just wrote to 0.075, which is the actual number we should be using. And I'm just going to hit show prices, and there's my titles, and there's my, oh, that's just lovely. Everything lines up well. And on day 1, or day 0, the price is $57, and the savings is nothing. Now it's time to start writing code to make that move. So here I'm supposed to determine each day's price. And again, according to the flowchart, first thing I want to do is start my while statement, then display the results. Here's my display, or add to the output. Right? That's the second line inside, or the first line inside the loop. So my loop has to come before this. In C#, a while loop starts with the keyword while. Then in parentheses, your condition, the day price is greater than 1. If it's equal to 1, we don't need to reduce it anymore. And actually, I shouldn't use 1, I should use min price. So this says, keep going as long as this condition is true. While this condition is true, keep going. When the condition becomes false, we automatically jump out of the loop. So at the end here, we need curly brackets. Like all other blocks, if there's only one statement inside your loop, we have lots of statements here, 1, 2, 3, 4. If there's only one, you don't need the curly brackets, but most people put them on anyways. And here is the end of my loop. Good idea to mark it. And notice the results statement is automatically indented. Now don't follow, but I'm going to run this again. What's going to happen? Karen's anticipating already. If I run this program right now, what's going to happen? Karen, you know? When is day price ever going to be greater than, or when is it ever going to be less than the min price? I'm not changing it. I'm never changing it. So it goes and it goes and it goes and it goes. And what we can't see is that it's actually running behind the scenes. And at some point, it's going to concatenate the string so huge that C# is going to throw a fit and say, I can't do that anymore. But I don't want to wait that long. This is an endless loop. This is what your program, what it looks like in an endless loop. It'll often just sit there. But I just wrote the loop, and it was working before, so I know it has to be my loop. Just like with a for loop, there's a loop control variable, day price. It has to change inside the loop so that at some point the day price ultimately becomes equal to or less than the min price so that my loop ends. If it never changes, it can never reach that value. Now, I wasn't following my code here, so now it's time to follow my code. And my code said bump the day up by 1. Then calculate the new day price. Here we go. The day price is going to shrink. The day price is equal to whatever it is now minus, that's a goofy way of doing it. Let's do it this way, times, no, let's do it the other way, I'm sorry. The reason we did it the other way is because this is percent off. This is percent off, and if I wanted to, I could flip that around, but let's just do it this way. This is equal to the day price minus my reduction, which is the day price times the percent off. Do I need the parentheses? No. Do they help with the readability? Debatable. But it definitely says do this first. So this will calculate, if it's $100, 10% off, this will calculate a $10 reduction. Subtract it from the day price, put it right back into the day price. I could shorten this a little bit. I don't know if it improves readability. That's the shortened version. Use the shortcut operator minus equals, because here's day price, minus. Whichever one of those suits you. They both do exactly the same thing. One's just written slightly different. And then I want to know what's my savings. And this is a percentage. So the savings is equal to 1 minus this. I don't want to know how much I'm paying. I want to know how much I'm saving. So I'm going to calculate how much I'm paying and subtract that from 1. I am paying my current day price divided by the original price. So this is now what I'm paying. I'm paying 90%. But I'm saving 1 minus 90%, that's 10%. And that's formatted a little bit later. What do you complain about? Decimal, so this is the org price, this is the day price, 1 minus, oh, this is a double. These are decimals, so I'm going to typecast this equation to a double. There we go. And up here, day price is a decimal, but this needs to be a decimal, so a little typecasting. How come I typecast this one for a decimal? Because its target over here is a decimal. This target is a double, so I typecast for a double. When you're typecasting, make everybody the same as the target. You should be in pretty good shape. So that's now the bottom of my loop. And then it automatically goes up. And then what? Display the results. I already have that. Oh, we're done. Really? Wow. That wasn't bad. What I did is what I recommend you do if you can't get your head around a loop. What do I got to do in the loop? Well, make it happen once. Write the code to make it happen, whatever it is you need to make happen, once. Then wrap a loop around it. This is all the stuff that I needed to do, and I wrapped a loop at the beginning, at the end. The other alternative is you can't get your head around a loop, flowchart it. Pseudocode isn't going to help you. If you can't code it, you're not going to be able to pseudocode it. Flowchart it. What do you want to do? And then test. So here's my original price of $57, and we're going to take a 7.5% reduction every day. Go. And now I get answers. So on day one, the price comes down to $52.73. I've saved 7.5% and so on. Sometime this just keeps getting smaller and smaller and smaller. And notice here the difference is cents now. You could use this if you were the savvy shopper and say, at what point does the difference really not make a lot of difference to me? Okay, it's 13 cents. Maybe it's up in here someplace where it's still going down by $1.50. I don't know. But we didn't know when this loop was going to end. The program told us here's $1.07, so that tells me that the next amount of money that I'm taking off is a little more than $1, or a little more than 10 cents. And that takes us under $1. So this program never displays that less than $1 price. The point here is not this progressive sale. It's interesting. The point here is we can loop. Even if we don't know how many times we need to loop, we can still loop as long as we can define a condition that says, here's when you stop. Next semester in Programming Logic Intermediate, you're going to learn about a special command called EOF, end of file. Keep reading the contents of this text file until there isn't any more, until you hit the end. But we don't know how many lines that is. We can't anticipate it. So we can write a while loop that goes through it until it hits the end and then it quits. This is a pretest loop because it's at the top. If I run this program again, with an original price of $1 and a reduction of 15%, I get nothing because it skipped my loop right away. Now, it didn't display the original price. Might have been nice to see that, but the original price is $1. I can see it right there. And there's never going to be any reductions because it's already, why would you do that? Well, I might have a whole file full of items that I want to put on sale and process each one of them. Some of them maybe will be reduced and some of them won't. This program demonstrates that if it's already at $1, it won't take it down anymore. Let's just do one more for fun at 15%, and it's going to take us 28 days, a month of savings to get that down to $1. People might want to look at that, the shop owners, and say, that's taking too long. Don't want to sell for a whole month. How about 25% a day? Well, 16 days, and it's jumping down pretty quickly from $100 to $10 in 8 days. If I wanted to buy this pretty bad, I'd be looking at it somewhere around 56, 40. I like 20% reductions. But Pam might be looking for the bargain, so she'll wait till day 8, because after that, it's only going down $1 or $2 anyways. So programs can help you do, just like spreadsheets, help you make decisions. Questions about the loop? I don't think the concepts are hard, but the logic can be very tricky. I'm giving it to you here. I gave you the design. Coming up with the logic of your own loops, I can talk till I'm blue in the face and you won't come up with them. Got to try them. And then find out what's wrong. And a lot of times what's tricky is what do I do inside and outside of the loop? I don't want to see these titles. If I move these inside of the loop, then for every day it repeats the titles over and over and over again. If you make that mistake, you go, oops, don't look, make sure nobody's looking, move them back outside of the loop. But a flowchart can really help. If you're not sure about your loops in your last program, flowchart them. Have the lab assistants or me look at the flowchart, because you saw that if I had the flowchart, writing loops ain't so bad. It's not like for loops where you got to do all these complicated transformations. Here, it's pretty much take it over and do the right indentation. Okay, we can close that one. The next one we're going to do, and I was going to prep for this, but my last class kept me a little busy, so let me see if I can wing this here real quick. In your networking class, you learned a little bit about binary number systems, maybe a little bit about hexadecimal number systems. You recognize the term, U-pings going out. I've heard that somewhere before. I don't understand it, but I heard it. At some point, you might need to understand it. Right now, I think it's kind of disappearing from our curriculum, but here's your introduction to it. I'm going to insert a quick little table here. And let's make it about that wide. Binary numbers look something like this, right? Yeah, let's make the numbers a little bigger so we can see what's going on here. That looks like a binary number. But what does that represent? What number does it represent? Okay. And here's what a hexadecimal number looks like. Maybe. That's a hexadecimal number. What does that represent? It represents numbers that you and I don't recognize, but they're still numbers. There's still values associated with them. Each one of these columns has a value. And one more number system. That's our number system. But that number you recognize, right? That's 1,234,567. You know what that, your brain can process that. Computers can't. Computers can only process this. This is kind of an in-between. We don't do real well with big, long strings of ones and zeros. Computers do. This is kind of a compromise. That's why hexadecimals exists, because it's a compromise between our number system and the binary that computers use. But these numbers all have meaning. In our number system, this is the ones column, right? And this is the tens column. And this is the hundreds column. And the thousands and so on. Where do these come from? We have 10 digits in our number system, 0 through 9. So every column, every one of these number systems has a 1 in the first column. But then the binary number system only has 2 digits in it, zeros and ones. So here we multiplied by 10. Here we multiply by 2. This is the 2's column, and then the 4's column. Let's try that again. 4's column, and the 8's column, and the 16's column. We just multiply by 2 each time going across. And the 64. Now this isn't what the lecture is about. All right. But just real quick, this binary number, 1010101, represents a 64 in our number system. These are the values in our number system. 64 and a 16, that's 80 for 85. That number up there in binary represents 85. If it's stored as a character, it's ASCII character number 85, whatever that is. Probably back into the alphabet someplace, capital letter. What about this one? Well, in hexadecimal, we have 16 digits, 16 different digits, 0 through 9, A, B, C, D, E, and F. So this is the ones column. This is the 16s column. This is the 256s column. This is the 4096s column, and then I forget what the rest of them are. I thought I was doing pretty good getting to 4096. Now, you don't have to completely understand that, but recognize that we often want to translate these kinds of numbers. And for the next program, what I want to do is automatically generate these column headers. My user is going to tell me what the maximum value that I want to hit is, say 1,000,000, something like that. How many of these ones and zeros would it take me to hit so I could have 1,000,000? Criminy, I've already got 1, 2, 3, 4, 5, 6, 7, 8, 7 columns, and I've only hit the 64. I mean, what would it take to get, that's what I want to know. And what are the column headings? So that's what we're going to generate. So going into the next program then, the column headings program. Let's take a look at its design first. And while that design is loading here, let's bring it actually in so it's ready to go in a minute. Okay, so here's my design again. Not going to pay attention to me. Oh, really? There we go. So here again, split screen, pseudocode, pretest loop. Whenever we do number systems, there has to be one column, otherwise you got no digits. So we're going to go through this process at least once. If you have to go through it at least once, you do what's called a post-test loop. You do the loop, and then at the bottom, you check to see if you should go back up again. But how do we know where the top of the loop is? We know the top of the loop in flowcharting. I put a little circle up there called do. In pseudocode, I put the word do. Guess what we're going to do in C#? Do. And the condition is down at the bottom, and this is some of the weirdest looking syntax that you'll see. Do curly bracket. Here's what you do, right? Between the curly brackets. Then a while condition that's in parentheses, and then a semicolon after the while condition. That's just scary for me when I put that on there. The good news is I don't do a lot of post-test loops. Do a lot of fors, for each loops, a fair number of pre-test loops, not a lot of post-test loops. So I don't have to get all sweaty about that semicolon at the end of a while statement. But this is the way it works. You start here, and it just says, oh, okay, that's the top of the loop, whatever. Process, 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 process. Then when it hits the bottom, it doesn't quit, it checks the condition. If it's still true, if this condition is still true, it automatically goes back up, and here we go. You have to be the programmer and know this. It automatically goes back up to the top, which is marked by a do. Here you notice I didn't mark it with a connector. Makes flowcharting a little easier if you mark it with a connector. Just put the word do in there. There are other kinds of loops different for different languages, but for us, this is the one you'll probably want to use because it matches what we can do. Other languages allow you to repeat until. In other words, when this is true, kick out. Instead of when it's true, keep going. Other languages, not this one. So there's the C# version of that. Now back to our design. I want to generate those column headings across the top. Remember, they go from right to left, more or less. The 1s column, the 2s, the 4s, the 8s, the 16s. So I'm going to start my column heading out at 1. Again, my results is the empty string. I get the number base. You want base 16, base 10? Do you want base 2? We can even do base 6. If you end up with aliens coming in with 3 fingers on each hand, we can learn how to count in their number system. What's the maximum number we want to worry about? All of that is input from the user. And then each column, what's its value? Every column value starts off at 1. Doesn't matter. Even those aliens come in with their number system, the first symbol, first column represents the 1s column. How many 1s do we have? Then our loop. Here's the do. While the column value is less than the max. Keep doing this over and over and over again. Once again, there's a loop control variable here. The column value is the loop control variable. It has to change. If it is forever less than max, this loop loops forever, and we see nothing happening. Your program just sits there. Behind the scenes, it's really, really busy. But we can't see it. Every time through the loop, we display the current values, then bump up our counter and determine the new column value. Geez, that ought to be simple. Yeah, 3 steps inside the loop. That's it. Here's the pseudocode version. Initialize, initialize, initialize. Add these to the results. Bump up the counter. And here's the while statement at the bottom of the loop. Makes me go back up in pseudocode. Pseudocode, we don't worry about the curly brackets, so it's just do and while. Geez, sounds simple. Let's go for it. C#. Okay, I want to see the code here. I got all kinds of stuff hiding. I guess I should have shown you the form as well. Okay, here's my form. You put in the number, either 10's number, the base 10 number system, the base 2 number system, base 16 called hexadecimal number system. And here's my maximum value. Notice it's got commas in it, so if I'm going to read that in, I'm going to have to unformat it. And just again, a button, and all the lists show up here. So let's see how that works. Make it bigger. Okay. Now, what did I have in the early parts? The setup. Most loops have some kind of setup to them. Initializing values for the loop. My setup said set counter value at 1, or the C, there it is, 1. The results to the empty string, and then bring in the number base and the maximum number. Did that. Notice I unformatted my millions here. And set the column value to 1. Okay, did that. Now, my design says, start your loop. Well, beforehand, again, if you're not sure, you can write the code to make this process once. And once again, I have another one of these fancy schmancy string formats with 2 values. Value number 0, value number 1. This one prints in 3 spaces. This one prints in 15 spaces with commas. So this again should run, and this one uses a different technique. Notice my column headers are outside the box. Those are just labels. Instead of putting them inside, I put them at the top. That way I don't scroll away. They're just labels, and all I'm hoping for is that my numbers line up nice and neat underneath. Let's go base 10 for right now. Beauteous. Now we can get started. So now I want to wrap a loop around this. This is where my loop is. That statement to add it to the results is the top of the loop. So right here, I want to start my loop. In C#, the loop simply starts with a post-test loop, simply starts with the keyword do and a curly bracket. In a do-while loop, a post-test loop, the curly brackets are absolutely required. I think I've never written one without. I guess I shouldn't say that. I've never written one without. It gets really confusing. Now down here is the bottom of my loop. So you start with an end curly bracket because it marks the end of the loop. Then the while condition. While my current, what's my current value? Column value is less than, looking at my yellow diamond over there, less than the maximum value, which is max. Semicolon. Yes, sir. Okay, there you go. Semicolon. So I'm following my design. According to my design, after I add this to the results, I've added all this junk to the results. After that, I need to bump up my counter. If you're counting stuff like I am here, counting columns, counting days like I was in the last one, you are responsible now for updating that counter inside of the loop. Our for each loop, we didn't have to worry about counting anything. It just did it, beginning to end. A regular for loop, we had to do it, but we put it inside the for statement, and the for statement took care of it. Every time through the loop, it bumped it up. Another very common mistake when you have these pre-test, post-test loops, you have a counter, you don't bump up the counter. The other thing I want to know is what's the new column value? What's the next column value? The next column value is equal to the old column value times the base. Remember when we were doing these, we said 1 times 2 times 2 times 2 times 2, previous column times the base. 1 times 16 times 16 times 16, previous column balance value times the base. And we're done. Well, we should test. The easiest test is a number system we're familiar with, the base 10 number system. I expect to see ones, tens, hundreds, thousands, tens, hundreds, and millions. How come I didn't get the millions? Because we said less than. So let's change that to say less than or equal to. So you can tweak the loop. Less than or equal to the max. Not while you're running. That way I should see a million. Go. There we go. And notice it took 1, 2, 3, 4, 5, 6, 7 columns to get to a million. Let's do space 16. The next one after 65,000. 65,000 times 16 is 1 million and change. I forget what 1 megabyte is exactly. But this tells me that if I want to get to up to about 1 million, I need only 5 columns. Because the 6th column is going to have a 1 in it, and everything after it will be bigger than 1 million already. I only need 5 columns in the hexadecimal number system to get to 1 million. Because I have 16 fingers, I have 16 digits to use from. And finally, what are the column headers for base 2? 1, 2, 4, 8, you can see. And I want you to recognize something here. This is my networking fundamental stuff coming to me. That 256, does it sound familiar? It's a base 16 column header too. Look, 1, 1, 2, 3, 4, 16, 1, 2, 3, 4, 256, 1, 2, 3, 4, 4096. Every fourth one in the binary number system is also represented in hexadecimal. But notice it didn't take very long. 21 columns. It looked like it was going to take forever, right? Because we were doing 1s and 2s and 4s and 8s. But once the numbers start going up, they go up in a hurry. The 21st column would be the 1,064,000 and change whatever column header. And we don't need it. If we want to represent the number 1 million in binary, we only need 20 columns. And these are the column headers. So this is a program you just want to keep in your flash drive someplace in case somebody ever wants you to convert binary numbers or hexadecimal numbers. This can help you do it. Doesn't do the conversion. If all you want to do is a conversion, use the calculators built into Windows. It'll do it. The point again is not the binary number hexadecimal number system. It's a loop. I don't know how many cycles to go through this loop to get from 1 to 1 million. I don't know. So I can't write a for loop. Again, if I wanted to, I could do a lot of research and dig up a formula someplace that would calculate it for me using probably logarithms. And I had to figure out how to put logarithms into my C# programs. Just do a do loop. The do while loop that says keep doing it over and over and over again until you get bigger than the max. 3 different kinds of loops. Most common, for loop. To the point where we even use it when we shouldn't. But for loops, for each loops, very, very common. I believe while you're doing your labs today, when I'm not answering your questions, I'm going to be taking a quick look at my solution to the assignment tracker program. I don't think you need the pre and post test loops to solve the assignment tracker program. I don't think so. That program's a little bit about loops, but more than anything, it's about list boxes and combo boxes and how do you make them do their stuff, and a little bit about loops. Back to my review, 3 kinds of loops. Most of the time we use for loops and for each loops. Occasionally, you'll use a pretest loop like we did for our progression, where you have a condition at the top that could be false immediately and you skip it. We saw that happen. Check the condition at the top. The condition is true, you keep looping. As soon as the condition becomes false, you jump up. Same thing here. When we get to the bottom, however, we make our decision. So we have to go through this process. There is no way to skip from here down to here. You have to go through this process. If this condition is still true when you get down here, we go back up to the do and keep doing that over and over and over again until the loop control variable, until the loop control condition is false and it stops. Pre and post test loops, you're responsible for counting, for somehow changing this loop control variable. Because if the loop control variable never changes, or I've seen for loops that says, keep going until x is less than 0. And then they keep adding to x. Wait a minute, we're going the wrong way. Right? That's an endless loop. We're changing x every time through the loop, but it's going the wrong way. An endless loop, an infinite loop, simply a loop that never can't end. There's no logic to it that makes it end. You almost never write those. Those are by accident. And you never submit them because your program just sits there. It's conceivable, I guess, you could get really creative and write a loop that would go forever, but only in certain circumstances, and maybe you wouldn't recognize it. But usually endless loops, you sense them right away, particularly if you're testing in pieces like you should. Sarah. I'm sorry, a little louder for us old guys. Can this, you mean this one?
Yeah.
Could I write it as a pretest loop? Yeah, probably. Because I could come up here and say as long as the column value is less than the max, and as long as it doesn't start out that way, it should be fine. Okay. But if for some reason the column value is 1 and the max is 0, then we get no columns. Okay. This one at least will give me 1 column value that you need. To represent the number 0, you need 1 column. And so this is more accurate. But yes, I could flip it around, but it has some risks. The price one, it's possible if I put in the $1 or the 75-cent item that it skips it completely. I want it to skip and say, no, I'm not reducing this in price. That's why that one's written that way. Normally, I'm thinking like you. I write a pretest. If I can't use a for loop, I write a pretest loop. If that doesn't work for me, maybe a post-test loop. But the thought process I usually go through in my head is, am I always going to go through this at least once? If the answer is yes, I'm going to go through it at least once. Then I'll write a post-test loop. That's the question I ask myself. That's the same question I had at the top of the notes someplace when we were trying to figure out what kind of a loop should I use. Do you know how many times you're going to loop? Yes, for loop. If you don't, do you have to go through it at least once? Yes, post-test loop. Otherwise, it must be a pretest loop. Those are the only 3. For each being a hybrid of the for loop. Congratulations, your head didn't explode after 16 and a half weeks of programming logic beginning. That's a good sign. Still got a fair amount of work to do. Okay. Remember, if you want a shot at an update, I got to see it on Friday. So if you want an update to your worksheet, by Friday. If you want an update to your assignment tracker program, get it to me Friday. A lot of people ask me, is it a good idea if it doesn't work, it's only half done to get it turned? No, I wouldn't think so. What are you gaining? You're having me check to see what you still have to do instead of you looking at it. I don't know. I think some of these scores that you're getting, I'm getting a lot of scores that tell me you're not using the evaluation sheet. And it's probably because you put it off till the last day and you got to crank it in there real fast so you don't lose your points. Probably going to lose them anyways. But some of these scores, 12, 13 out of 20, it's got to work on your psyche a little bit, I would think. I'd much rather get 18s and turn them in a little bit late and maybe use an NQA card. But it's too late for NQA cards. Don't forget NQA cards. If you want your points, sign them and give them to me. And I will log them and then double check my logging to make sure I did it right, because it's complicated. So that the grade book counts them as extra credit. It's a little complicated. But in your grade book, there should be an NQA column that shows points now once you turn your cards in, that shows points that you've earned for not using those NQA cards. Questions for me? Then you're in lab. The lab assistants and I will be here during regular scheduled times, which is just about always, to help you with any issues you have.